Hi, it's Rachel. Hey, once again, I'm referring to Penrose's book on page 242, where entropy is described as a cup of water that drops water onto a carpet, and then the carpet water evaporates in any which way direction. And I say, okay, it's random when it's evaporating. We all know that. However, we can devise mechanical ways to collect those random evaporation waves. And that, for example, is a conical shape on which the evaporation of the particles condenses and gives us little droplets. So, is it a colligative property of the material? Is it a property or a mechanical property that we can apply to actually condense those particles? In other words, when we're looking at the conical null space, and we see a light beam being bent, can we actually collect the properties of each one of the particles that is going to be scattered in one of these Wessel planes? And the answer is, I think, looking at what we have on Earth, if you want to be earthling, not cosmological, we're looking at Earth. We're seeing particles that are scattered out of the cup, and they're water molecules, and they hit the carpet, and then they evaporate. Yes, we can collect them back if we have a special shape. Well, why can't we actually apply this to the actual null space? In other words, the ray, the bent ray. So that's something to think about. How can we apply this situation to this situation? We're condensing. Can we condense light? Well, the realization of the reality of a beam of light is that it either penetrates and refracts or reflects. So what we're looking at is a situation where we have to apply some type of mechanical measure to condense the light beam and have it condense and essentially apparently drop or realize itself. Can we do that? This is in relation to having a pad where you can actually condense the energy you need to make a battery recharge and not scatter any energy. In other words, a little pad where the energy is going to come down, not scatter out, but condense. And it's going to condense into that pad to recharge your phone or recharge enough that you can apply whatever necessary recharge energies you need into your automobile or your motorcycle, 12 volts or more eventually. So let's look into the shape of what is going to be condensing that energy rather than studying the scattering each one of those particles into oblivious who knows where. We decided that yes, you have a cup that drops water into the carpet, the water evaporates, but yes, you can condense it into one point if you want to. So let's mimic that rather than anything else, is what I say. This is on page 243 of Penrose. That's what I gather from it. Let's approach it from there. I was working for Duracell and that's what I thought of.